So this is a little bit of an experiment, as you can see. And what I'm doing here is eating my own dog food. So the talk that I'm giving about is actually about the stuff that I'm showing the talk with. So the video, the live video that you're seeing there is actually provided with the software that we've written. So the software that we've written is, so this whole thing is running in a Chrome browser. It's using WebRTC, which is real-time conferencing for web pages. So what you're seeing here is a web page presentation. It's actually deck.js, which is a slide presentation tool for the web. And I've integrated just a little bit of our own RTC.io technology. So I work for NICTA these days, and together with Damon Earlman, we've developed this thing called RTC.io. If everything goes well, you should be seeing the second page now. Excellent. So what WebRTC is about peer-to-peer video, audio, and data communication. So that's browser to browser, based on a full open source stack. Then what you get in the browser with WebRTC is plugin free video conferencing, basically, or audio conferencing, or peer-to-peer data with a native JavaScript API. For video conferencing, you actually get quite a high quality of service. You get low latency, modern codecs, essentially the same codec that Tim's using for the live streaming, which is WebM. At least the default setup. Tim can fall back to Flash. This one won't fall back to Flash because it's just using native browser APIs. It's actually encrypted, so end-to-end, it's encrypted from browser to browser, unless you have a forwarding server in the middle. But we're actually doing this directly peer-to-peer, so we're fully encrypted here. We only need to use forwarding servers if we have a complicated set of firewalls set up. Fortunately, the conference LCA has opened all the firewalls to us, so we can transmit this easily. So what's happening here, to be going into a little bit more detail, is we're on the left. I'm a little bit loud. I can hear myself. Okay, so on the left, you can see that the first browser pulls the web page from the server. That's number one. Then it asks the web page for access to the camera, which Jonathan has given on your end, and I've given on my end. So I'm user 2 on the other end there, and now we have both cameras connected to the web page in the web browser. So in number 3, both of our web pages connect to a signaling server. We need the signaling server to be able to tell each other that we're there, basically to exchange information about, well, we're going to set up a video conference now. So number 3 is we both tell the signaling server that we're there. Number 4 is the signaling server forwards on those messages to each the other one. So now we know about each other, and we can connect directly, which is number 5. First, we negotiate which codec we use, which video quality are we using, video and audio or data only, which encryption are we using, etc., etc. And all of that, once the negotiation has happened, leads to the media flowing, so we can directly speak to each other. I've got a party going on in the back. I hope you don't hear that. Sorry? I'll just let out a shout back there. Hold on a second. Sorry about that. So what software are we using here? As a web server, in this case, this with this particular application or this particular demo, we're using Apache. I can use Apache on localhost. This one that we use here is on HTML5videoguide.net. It may actually be Nginx, I'm not quite sure. But it's an ordinary web server. And as a signaling server, we are using our own signaling tool developed. It's running at RTC.io switchboard. So what's RTC.io? So my colleague Damon Earlman, I just wanted to mention him as well because he's done most of the work. After I've done the basic demos and he's put proper node.js code. So we've got a little guy here, we call him Artio adequately for RTC.io. Artio simplifies coding on the client, so on a web page. Also provides node modules for setting up a signaling server and doing all the server-side stuff. And as part of the code, you can run a signaling server and a web server together as a node server. So we're allowing different levels of usage for WebRTC here. So we've got one which is completely fully declarative. Fully declarative means you only have to write HTML to get this going. And that's exactly what I've done with this particular demo here that you can see. The web page, the HTML page, basically has just these few little tags. There's a meta tag, in which we declare the signal host. So that's the signaling server. And then we've got two videos. One is the local video, which is in each of our cases the local camera. And one is the peer. And we connect that peer to the other remote video by giving it the stream ID. So the stream ID is local. And then, of course, you need to get our JavaScript library, which is just glue.js in this case. You get it from GitHub. You don't need to do any JavaScript coding at all. I didn't do much JavaScript coding for this at all in this page here. That's all I needed to do, and it runs. If you want to see how WebRTC is performing, you need to go to Chrome WebRTC internals. There's a lot of statistics there, which is quite nice to see. But we won't go there right now because we've got a lot to go through still. So there's one demo app which you can install using RTC Glue. It uses Node.js with Express as a web server. RTC Glue, which is one of the libraries that we've developed at RTC-io. That's the client-side stuff, and RTC Switchboard is the signaling server, so that's on the server side. When you install it, that's all you have to do. You run git clone, you npm install. Once that's finished, you do npm start. There's a default port that it's running on, that's 1337. If you go to localhost 1337, you can see that demo running live in your browser. You can see that in the browser on the right, I've got two tabs open just to be able to demonstrate this. So it's the same video, but it's actually a video conference between the two tabs in the browser. Questions? No? Okay. So that's the simplest part. That's all doing it as HTML. Now, how do you run a signaling server? For the signaling server, we use Node.js with a little extension that's called RTC Switchboard. And RTC Switchboard is using Primus.io as a web server. So they're all different node modules that you just have to put together, and it already runs your signaling servers as easy as just really this little piece of code, server.listen on the port, and that's all it does. It listens on the port. When it gets a message, it sends it to its peer, etc., etc. Is there a question? No? Okay. Same here as before. We've got a little demo app. It's called RTC.io Demo Signaler. It uses Node.js with Express as a web server, although it wouldn't really need to do that because we really only want to run the signaling server. So on the client side, we have RTC Signaler. On the server side, we have RTC Switchboard. And just as before, what you do is git clone, that particular repository, npm install. When that's done, you run npm start. Again, you can do this locally on your local host. Here, the demonstration shows just a little IRC, basically, or chat application. So I can chat between these two tabs, enter a message, and colors them depending on which one you are. So simple enough. Now, if you want to do everything in node.js, you don't want to do it with HTML, you want to actually do JavaScript. And so the third approach that we have is a JavaScript-based peer computing approach. It gives you more control on the client side, but you need to use two lower-level libraries. They're called RTC Media and RTC Quick Connect, and they're built for Node.js. So this is what that looks like. So this does exactly the same as a little bit of HTML code that I had before, except it uses Quick Connect and RTC Media to set up your local video and your remote video. And you can see you have to add stream, you have to add event listeners, and then you have to run Quick Connect and connect some functions. So it's a fair amount more work, but you get a lot more control. And there's another application that we've written for that, a demo application, which is called RTC.io Demo Quick Connect. Again, it uses Node.js with Express as the web server, RTC Media to do the camera mic access, RTC Quick Connect for the peer connection, and Switchboard for the server-side signaling. Looks like this. So clone, npm install, and npm run. This one runs on port 3000. I don't know why. We just put that on a different port. And when you run that, you can get a peer connection, just like the one before, between the two tabs. This one actually also has a chat window in it, but I think the chat is only doing what we did before with the switch board, so it's going via the signaling server. This is not actually using the data channel. Now, that was all audio and video so far. If you wanted to do data exchange, peer-to-peer data, you'd want to use something a little bit different. We've developed a specific library called RTC Mesh, and it allows you to send data between lots of peers. So you could have a big mesh of peers. You could have, let's say, dozens, maybe even hundreds of peers. And when you send something, it gets sent to all of these others. So this is interesting, for example, if you wanted to implement a game or something where you want to do, want to make use of the peer-to-peer capabilities of WebRTC for messaging each other directly. So this shows a little bit of code. It's not very difficult, but you use Mesh for that, RTC Mesh. Again, we've got a demo application that uses RTC Mesh with Switchboard as the security server. When you run that, we've actually built this with Fabric. I don't know if you've heard of Fabric. Fabric is a Fabric database. Gives you basically all the capabilities that a interactive editor gives you, like a whiteboard, a sheet whiteboard type stuff. But you can develop all of that in JavaScript. So when you run that with an npm start, you'll see a toolbox being drawn and the word hello. That's all in a canvas. And when you make it bigger or you move the hello text, it also gets a second tab. Or however many tabs you want to have open, they all go in sync. So this far, we've seen all the three features of WebRTC, which is audio conferencing, audio and video conferencing, and data conferencing. Now, oftentimes we have to deal with firewalls, and I've so far ignored that. It's often a big issue, but it's this functionality in WebRTC in the spec that helps us deal with it. What we get is two functionalities. The first one is a stun server. Sometimes we don't actually have an IP address. We have a dynamically allocated IP address, which people outside our network, outside our firewall, sees different to us. So we use a stun server that tells us our IP address before we go to the signaling server and can connect to our peer. and then everything else is the same. But sometimes our firewall is actually worse and doesn't let us connect directly, even if we know our IP address, because we use some UDP ports or TCP ports to connect for direct data exchange. So here, what we put in between is a turn server, and each one of the peers can connect to a turn server, which then basically takes on our own role to connect to the other end. So as you can see in step 7 and 8, we've got turn servers included in there. Software to run standard turn servers are these. RFC 5766 turn server is a funny named turn server, but it's the most up-to-date developed turn server and stun server, also called iServer, that I can highly recommend. It's the one we are running. Then there's ReStun-D, which is also pretty good. Not quite as up-to-date with all the current WebRTC standards, but they're both open source. So here's what you have to do to include the stun and turn server into a peer connection. There is a parameter to the RTC peer connection object. So when you create that in JavaScript, you just give that iServers. That's a stun server and 2 turn servers here. These are run by Google and with Google credentials. They're the only ones, really, the only turn servers that are publicly available, because of course turn servers require a lot of bandwidth. Stun servers, you can get hundreds of them freely available on the internet because they don't do a lot. They tell you your IP address, so that doesn't really require that much, that many resources. So that was that. Here's my email and Damon's email if you're interested, if you want to learn more. There's also the link to the project and the GitHub repository. My slides are up on the internet, as you can see in the URL in the browser. Questions? Sorry? Oh, probably. Uh-oh. I'm not on my Ethernet. I was going to get on the Ethernet here. I'm on the wireless. That's possible that sometimes stops. Ah, okay, good. Yeah, so the audio is the most important part. I don't really care that much about the video. So you can download all of these presentations from my GitHub account as well, this whole presentation. So if you want to write your own one and do this yourself, feel free. I didn't put the link up here, but my GitHub account is github.com/Silvia Pfeiffer. So find it there, my LCA talk, and try it out. Use the latest Chrome and have fun with it. There's somebody back there. Thank you. I think someone at the back has their hand up. Oh, that's the camera. Okay. No worries. Well, I won't hold you back from your break. Enjoy your afternoon tea.